Welcome back. The objective of this video is to run through a process of analyzing and graphing a rational function. Our curriculum gives us a guide here, a step-by-step guide of things to do. I do things in a little bit different order. There's things I see and like to do first. There may be things that you like to do in a different order as well. But there are some commonalities between what we do. So our guide here says to factor our function and get it into factored form, and then find the domain of the function. Determine the intercepts, any x-intercepts where the numerator is equal to 0. The y-intercept when we put 0 in for x and solve, or we can just eyeball that from our original one, usually looking at the constants, numerator over denominator. Find any real zeros of the denominator to determine the vertical asymptote. So we see where the denominator is equal to 0. That makes our fraction undefined. That's going to be the location of the vertical asymptotes. I look for a horizontal or oblique, or we've been calling them slant asymptotes, using the techniques we've had before. You can test for symmetry. We've got our test for symmetry that we've done earlier this semester. Sometimes you can just look at your graph and see the symmetry there. And then determine where the graph lies, being using the test for zeros or positive or negative. We can do that. Sometimes they're testing. A lot of times you don't even have to test because you've got your bridges and you know exactly where that's going to go. And then step 8 says graph any asymptotes, if any, found in step 5. Those are things I do like really early on and plot. So let's take a look at example 8 here, and we'll go ahead and follow that process. So use the procedure above, or use a procedure similar to what I'm going to outline here. So the first thing I'm going to do is factor this. I tried to factor the numerator. It's not factorable, unfortunately. So we're going to end up doing the quadratic formula, or completing the square. I would do the quadratic formula to get our zeros and our x-intercept. So we can't factor the numerator. The denominator we can factor. So our function r of x then is the unfactorable numerator all over our factored denominator 2 times x plus 2. So we have a vertical asymptote at x equals -2 because x plus 2 can't equal 0 and x can't equal -2. So we've got a vertical asymptote at x equals -2. We have a slant asymptote because our numerator, the leading coefficient in the numerator, is 1 more than the leading coefficient in the denominator. We don't have any holes because we don't have any slant factors that are going to cancel, and so we're not going to have a horizontal asymptote either. So we've got a slant asymptote here that we're going to deal with. So we can probably find that slant asymptote right away. We'll do a little long division. 2x plus 4 is our divisor. X squared plus 3x minus 2, so a little long division here. How many times does 2x go into x squared? Well, that's going to be 1/2 x. As I multiply back, I get x squared plus 2x. I subtract that entire quantity, and I get x minus 2. And then again, I ask myself, what's 2x, x divided by 2x? And that is 1/2. I multiply back. I get x minus 2. I subtract that whole quantity. I get 0, but I don't really need to do that. So my slant asymptote is y equals 1/2 x plus 1/2. Our y-intercept, we put 0 in for x and solve for y. That's just negative 2 over positive 4. So our y-intercept is at 0, 1/2. I beg your pardon, that's negative 1/2. And our x-intercept, we're going to have to do that by doing the quadratic formula. So let's take a break here and we'll at least plot the information that we have. Then we'll go back and do the x-intercepts and put those in after we do the quadratic formula. So I've taken a moment to plot our vertical asymptote at x equals negative 2, our slant asymptote at y equals 1/2 x plus 1/2, and then I've plotted our y-intercept at negative 1/2. I'll have to do the quadratic formula to find our x-intercepts. So in my numerator, my a value was 1, my b was 3, my c is negative 2. So using that quadratic function in my numerator, I do the quadratic formula to solve for x. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I end up with negative 3 plus or minus the square root of 9 plus 8 all over 2. So negative 3/2, because 2 is a common denominator to both of these terms, negative 3/2 plus or minus the square root of 17 over 2. So x equals negative 3/2 plus the square root of 17. That's a little bit more than 4. So this is, plus or minus about 2. So if I went to negative 3/2 and I went 2 units to the right, and I went to negative 3/2 and I went 2 units to the left, well, that's going to be approximately where my x-intercepts are going to be. Now this is the exact value of my x-intercepts, so I could write that as an ordered pair. So if I wanted to do that on a test or something, so we do negative 3/2 plus or minus the square root of 17 all over 2 and 0 are my two x-intercepts, and now I've plotted those 2 points. And now we are in a position to graph, and we're going to be able to do our entire graph here without any kind of testing at all. We have our y-intercept and our x-intercept here on the kind of the right half plane, and those are going to be our bridges across the x and y axis, and we're going to follow asymptotic behavior. So we'll just pass through those intercepts and do our asymptotic behavior, and our graph is going to look something like that. For all the x values greater than negative 2, that's going to look like that. And then on the left-hand side, for all our x values less than negative 2, again, we're going to do our asymptotic behavior from our bridge across the x-axis. So I can simply do asymptotic behavior here, and that is the graph of our function. We have no symmetry. Our domain, we can use any x we want other than negative 2. So it's going to be all real numbers except negative 2, or if you will, in interval notation, from negative infinity to negative 2, in union with negative 2 non-inclusive all the way out to positive infinity. So there we have graphed our rational function. We found the domain. We said there was no symmetry, and that's a really nice example, and you'll get some more practice with those when I see you in class.